So a wonderful subscriber sent me this book. Thank you very much. I'm very happy to have gotten it. This is actually a really good book for me. I'm very happy that I got it. I would have ordered it for myself, and it's a Dover book, so it's not that expensive, but I'm very thankful, and it's a really nice gesture. Thank you, thank you, thank you. So, George Andrews' Number Theory. I really like this book. Incredibly enough, it's got things that I don't have in any of my other introductory number theory books. It's got some really nice partition stuff that I do have in this book that's dedicated to partitions, of which I've never made a video because I've been waiting for when I get onto number theory. But if somebody wants to see a video about this book, let me know. And it's Theory of Partitions by George Andrews. That's what it is. Okay, so then on to the preface, or let me see. Sorry. See if I get it right. For some reason, I didn't get my camera to be completely. Yeah, so the big thing that I really, really like about this book that sets it apart from all the other number theory books that I have is the treatment of number theory from a combinatorial perspective. Very fresh, very interesting. And it talks a lot about partition functions, which I happen to find fascinating. And it also mentions the Jacobi triple identity, which is one of my favorite equations in mathematics. And I remember years ago, before I even had this channel, watching a video of Professor Murdy, I'm mispronouncing his name, from Canada, going over the Jacobi triple identity, and I really enjoyed watching that video. I'll see if I can find it and put it in to this video for this book. Okay, so then onto the table of contents. Your standard fare of number theory. Okay, Euclid's, Fermat's little theorem, Wilson's theorem, congruences, arithmetic functions, primitive roots, prime numbers, then the whole thing about quadratic reciprocity, but really, I think the thing that I really like about this book is these three chapters, all on partition theory, and something about geometric number theory. It's got a couple of proofs in the appendices. It also has hints and answers to selected exercises, which is great. So again, this first part of the book is similar to what you would find in other introductory number theory books, but the series aspect and the combinatorial aspect of number theory are heavily treated in this book, and I really, really like that. As a matter of fact, when I get back to number theory, which of course, because I'm doing so many other things that I need to do before I get back to it, it will take me years. I know for a fact that this book will be important to me when I do, either as a reference or even perhaps as a book in which I cover the partition theory sections. Diophantine equations. It's got a lot of good stuff. It is really well written, very approachable, lots of examples. Of course, of all these older books, they don't have as many problems as I would like. I like hundreds and hundreds of problems. But in number theory, one thing that I really like about the subject is you can just make up your own problems because you're iterating over things that are very similar. And so I did find myself, when I was studying number theory, both times, when I was teaching it to myself and when I took that University of Illinois online course, I found myself always eager and having fun with creating my own problems, which I really haven't done in any other subject. I think number theory just really lends itself to that. So I could easily turn this book into like a 700 problem book for myself if I wanted to. Lots of graphics, which I have not seen in any other book. The graphical perspective, the geometric perspective, there's a little bit of that in Rosen, but I think this book does it more. And because of all the combinatorics, it's got things that I have not seen in other books. Yeah. It's got some computational aspects, which Rosen has. Of course, these are very old style flowcharts, but a flowchart is a flowchart. You can still use it today you would program it in Python instead of Fortran or whatever language you would have done 30 years ago. Congruences. Yeah, some very interesting problems. Yeah, Fermat's theorem, Wilson's theorem. This is the meat of the thing. Chinese remainder theorem with some great examples. Yeah, I see no reason why this book would make, I mean, I see every reason, I should say it in the positive, why this book would make a very fine first book for somebody. Yes, absolutely. And some people are taken aback by Dover books and think, well, they're old, they're out of style, but the notation is modern, it works. And yeah, I would definitely, this book is up there as a Dover book with Mendelssohn's number systems and analysis, which I covered. I read the whole thing, and I have a playlist for in this channel. Yeah, actually, yeah, in case you're wondering, this is the book that I'm talking about. Another great Dover book, very modern, very readable. So I could easily see myself actually working through this particular Dover book. Mobius inversion. A topic of fascination for me, primitive roots. By the way, a great test for large language models like ChatGPT is to make it do primitive roots. Because it's one of those things that it's not a straightforward formula. It's not F equals MA like in mechanics. Unsolved problems, so many unsolved problems in number theory. Yeah. Legendre symbols. I've got a bunch of videos in my channel solving the Legendre symbols. I had so much fun with those. Yep, this diagram is used in the proof of quadratic reciprocity. I remember it. Yeah, see, this is very much in this book. I like it. And it's sort of new to me to see it this way. I believe so. Yeah, this is the part that I really would learn from in this book that is, I don't want to say unique to it, but really, really well done in gory detail. Yeah, all these partitions. All the generating functions. And I think we're getting close to the Jacobi triple identity. I know we're in the neighborhood. There it is. That's it. Yeah. Our next result is known as Jacobi's triple product identity. A beautiful equation. Look at that. A product of these three, this triple product, is equal to that summation. What a beautiful formula. Yeah, one of my favorite formulas in the little mathematics that I know. Then some partition identities with a graphical representation. Then Rogers Ramanujan identities. And I'm not sure if I'm mispronouncing Ramanujan's name, if it's Ramanujan. Please somebody correct me in the comments. You'll do me a favor. Yeah, these are very interesting. Series and product identities, Schur's theorem. Lattice points. I have not seen this before. This content is new to me. And the Dirichlet divisor problem is also new to me. Or at least I don't remember when I covered number theory. Then appendices, some proofs, some infinite series, double series, Some notes. So the chapters have notes. Then further reading. Got a couple of books here that I already looked up. They're on my hit list, at least one of them. And then a full bibliography. Weiss's book is on my hit list to get at some point. Hints and answers to selected exercises. And an index and some notation. And I'll finish with this right here so you can read it.